Hey guys, welcome back to Math from my desk. In today's video, I will be deriving the quadratic formula, which is essentially solvent for x in the equation ax squared plus bx plus c is equal to 0, where a, b, and c are constants. So let's go ahead and start. So the first thing I'm going to do is subtract c from both sides, which leaves me with ax squared plus bx in the left-hand side and negative c here in the right-hand side. Then what I'm going to do is I'm going to take a look at this coefficient of the x squared term, which in this case is a, and I'm going to divide both sides of the equation by a. So this is equivalent with multiplying by 1 over a. So when I go ahead and do this division, I'm going to end up here with, well, ax squared divided by a is simply x squared, and then bx divided by a is simply b over a times x. And here negative c over a is just negative c over a. So now what I'm going to do is I'm going to take a look at this b over a term, and in order to simplify the process later, when I want to solve for x, I'm going to go ahead and divide this b over a term by 2, which is the same thing as multiplying by 1/2, which leaves me with b over 2a. Then this b over 2a is something that I'm going to go ahead and square, which leaves me with b squared over, well, 2a squared is simply going to be 4a squared. So I'm going to take this b squared over 4a squared and add it to both sides of the equation. So now I'm left with x squared plus b over ax plus b squared over 4a squared is equal to negative c over a plus b squared over 4a squared. So now essentially this is just a process of simplification. So I'm going to go ahead and take a look at the left-hand side first and then the right-hand side. So when I look at the left-hand side, I notice that this is a quadratic. So you have an x squared, you have an x, and you have a constant term here. And so that means that I can go ahead and factor this out. Now, the way I'm going to factor this out is in a way that's going to give me a double repeating root. And the way I'm going to do that is by simply thinking about this intuitively. So in a quadratic, you're going to want your root to be something that adds to give you the c term, and multiplies to give you the c term, and adds to give you the b term, which is here, this here. And so since I want a double repeating root, the root is going to be the same. So that means that some value, let's call it v, times v, which is v squared, is going to be equal to b squared over 4a squared. And I'm going to want this v plus v to equal b over a. So when I solve for v here, this is the easiest. All I'm going to do is I'm going to square root both sides, and this leaves me with b over 2a. And let's verify if b over 2a works here. So v plus v is the same thing as v times 2. So if I do 2 times b over 2a, I'm effectively left with b over a, which is our b term. So this ends up working pretty nicely. So that means that the left-hand side factors to give us x plus b over 2a squared. And this is going to equal the the right-hand side, which is negative c over a plus b squared over 4a squared. So now what I'm going to do is I'm going to perform the addition here on the right-hand side. So I'm going to take a look at the greatest common denominator, which is 4a squared. And so what I'm going to do is I'm going to find the value, which I'm going to multiply this fraction here, negative c over a, to give us 4a squared here in the denominator, and that is obviously 4a, because 4a times a is 4a squared. So I can rewrite this here as x plus b over 2a squared is equal to negative c times 4a is negative 4ac, and then we're obviously going to have b squared, and in the denominator, as we wanted, we end up with 4a squared. And so I can rewrite this right-hand side as b squared minus 4ac divided by 4a squared, but I can go ahead and do that later. So now what I'm going to do is I'm going to go ahead and square root both sides to get rid of the squared here. And so I'm left with x plus b over 2a is equal to, well, I'm going to have the square root of b squared minus 4ac in the numerator, and here in the numerator the square root of 4a squared is simply 2a. So all I have to do now to solve for x is subtract both sides by b over 2a. Let me go ahead and rewrite this in the back of my paper since it doesn't seem like I have much space. So I have x plus b over 2a is equal to b squared minus 4ac, or the square root of b squared minus 4ac divided by 2a. So now all I have to do is subtract b over 2a from both sides. And what's nice about this is we already have a common denominator, which is 2a. So I'm left essentially with negative b. And then here we're gonna have a plus or minus. Why? Because the square roots can always has both positive and negative roots. This isn't a principal root, this is a square root. So for example, if we wanted the square root of let's say 4, negative 2 and 2 are both the answer. So we're gonna have plus or minus the square root of b squared minus 4ac divided by 2a, which was our common denominator. And this right here is the quadratic formula. The formula is therefore derived. Thank you for watching Math from my desk today.